Okay, let's have a go at this question. First thing that we're going to do is to find the modulus and the argument of w. So firstly, let's find the modulus of w. So that's going to be as if we are using Pythagoras. So actually it might be helpful for us to quickly have a look at what this complex number roughly looks like on an Argand diagram. So let's have a sketch. I can see in part B we're going to be doing this a little bit more, but 2 plus 2 root 3, probably somewhere like here. Ooh. Somewhere around here. And so I'm interested in forming some kind of right angle triangle with the radius like that, which is going to be the modulus, and like this. And I can see that this is 2 root 3. And this is 2. This is going to be the argument measured from the positive real axis anti-clockwise. So this is going to be the square root of 2 squared plus, in brackets, 2 root 3 squared, which is equal to the square root of 4 plus 4 times 3. So we've got root 16. And so we can see the modulus of this complex number is 4. So theta is going to equal to inverse tan of 2 root 3 over 3, which is equal to pi over 3. So finally, the complex number w in modulus argument form is equal to the modulus 4 in brackets cos of pi over 3 plus I sine of pi over 3. Now, a common mistake that you can make here is you can be tempted to multiply that back out, but if you were to multiply that back out, it would all just end up being like the original thing, and we wouldn't have actually put it into modulus argument form. Okay, now let's have a look at the second part. We're going to need to do a sketch of a diagram. There might also be a bit of work to do to get this to work. So that was part A. Okay, indicate on the Argand diagram the set of points which satisfy both of these inequalities. So I'm going to tackle them separately. I think that first point I'll make is that I'm not going to worry about the inequalities for the moment. I'm more going to try and sketch these loci. I'm going to sketch that the argument of z is equal to minus pi over 2. I'm going to sketch that the argument of z is equal to pi over 3. And I'm going to sketch the modulus of z is equal to 4. Thinking about what these are, this is going to be a ray, as is this, and this is going to be a circle. So, taking a couple of seconds to think about how I'm going to actually make sure I draw this Argand diagram reasonably. Try and think roughly where these things are. They're kind of all coming from the origin, so I'm kind of setting myself up. I'm going to have a fairly kind of standard axes looking something like this. Make sure that that's gone purple, that's okay. This is the imaginary axis, and here is the real axis. Purple and green kind of clashing slightly there. Okay, so the argument of z is equal to minus pi over 2. So this is all of the points that have an argument of minus pi over 2 compared to the origin. So sometimes we get z minus something inside here, but at the moment we don't. Okay, so it's going to be a line coming from the origin. I wonder if I can change the thickness of this. Going down. No. going straight down like this. Might be slightly hard to see. And the other one is going to be pi over 3, so it's going to be going off up at an angle of pi over 3. So just to be super clear about this, I've got an angle of pi over 3 here, and this angle is pi over 2, but since it is negative, we're going in the opposite direction, clockwise. Okay, now we want to draw our circle. This is the circle of center 0, i.e. the origin of our Argand diagram, and it has a radius of 4. So let's draw this. Like that. And we've got something like this. Okay. Don't need these anymore. So, we have got to find the points that have an argument of between here and here, and a modulus of less than or equal to the circle. So, because these are also equal to, we can say that we include the boundaries, and we're also going to include these lines. So it's inside the circle, but it's also in between the two arguments. So it's going to be these sections here. It's going to be up here. Do a bit of colouring in. You, of course, in an exam would do a light shading in this circumstance. Okay, so I'm quite happy with that. That is going to be the set of points Z, which satisfy both of those inequalities, the shaded region on the diagram. Right, now we've got to mark W on our Argand diagram. Well, we found that the modulus of the argument of W is pi over 3, and this line is at theta equals pi over 3, so we know it's on that line. We found that the modulus was 4, and we know that this circle has a modulus of 4. That means that I can say that my point W is on that point there, that intersection of that ray with the circle. It then says, find the greatest value of Z minus W. Now, Z minus W we can think of as being the distance from Z to W. So I want to find the point Z, which I know has to be in the shaded region, including the boundaries, the point W that is as far away from W as possible. So sometimes with these kinds of problems, you just have to kind of use a little bit of intuition. Sometimes you have to think about kind of the fact that the two furthest points the furthest point on a circle from another point is across the diameter. But looking at this, I'm quite comfortable that I'm happy that Z down here is going to be the furthest point, or it's kind of Z prime because it's one particular Z that is the furthest point from W. So the modulus of Z minus W is going to be the distance from there to here. So I've got to find the length of that line. So there's a little bit of stuff left to do here. I've got to think about what I'm going to do. But actually, it's never a problem for you to just go and start using some coordinate geometry, really. So if I was thinking of this as a coordinate, W would have the coordinate 2 root 3 as a coordinate, and Z would have the coordinate 0, minus 4. So really, I want to find the distance from 2 root 3 to 0, minus 4. So the greatest value of Z minus W is going to be the distance from those 2 points, which in the x direction is going to be 2 minus 0 squared, and in the y direction is going to be 2 root 3 minus 4, squared, which is, and we want to stay exact here, 4 plus, and I want to do a little bit of work. Am I going to play this carefully? Yes, I am. 4 plus 2 root 3 squared. I guess at this point you can kind of start to try and work this out by hand, or, and I'm going to cheat slightly, we could just go to our calculator and work this out. So we want to do the square root of 4 plus 2 root 3, all, careful about my thing, all squared. And hopefully it's going to give me it in modulus. No, it's not. So as a consequence of that, I need to go back and make sure that I can do this exactly. So I was going to be able to do a shortcut there, but I'm not able to. So let's give myself a bit more space to finish this off. Okay, so what have we got? Square root of 4 plus 16. This is when, if I was teaching, I'd be making all kinds of mistakes, and I'd have all you lot to check this with me. Plus 4 times 8 root 3 plus 8 root 3 plus 4 times 3. I'm going to check it doesn't want it. Find the greatest value of this. Yeah. So 20 plus 32 plus 16 root 3. And that's my final answer on that. Which, if we see in the calculator, is 7.73. Just 3 significant figures. Now this is where I'm wondering if I made any mistake. I'm going to double check myself. Nope, that does seem to be the answer to that question. Okay, I hope that was useful. Thank you very much.